Ladies and gentlemen, good evening. I hope to give you a couple of entertaining minutes. We are the group. Sorry, I had too much beer. We're the Human Interaction Creative Group, and tonight we will enact a little play, and we will play out to you what would happen, or how the ocean would change if there was a water landmass between the tip of South America and Antarctica. However, our funding was a little bit cut recently, so we had a bit of trouble and we couldn't run any models anymore. So we have decided, because we're really on a tight budget, that we have to play this model. To introduce myself, I will be your narrator for the evening, but as well I will be acting as Antarctica. So, hello. In addition to that, I would like to call the three most important continents we managed to get suitable actors for. So, first of all, can I ask for Africa to come and join me? Second of all, could I please call for my actor for Australia? And last but not least, please call for South America. Okay, we seem to have sorted out the land problem on Earth. Let's focus and let's get some water into this ocean. So, in the Ross Sea, there's a little gyre, which is called the Ross Gyre. So we're going to call the Ross Gyre. Okay, that's good. So we have the Ross Gyre, and he's a very small gyre at this stage, and he keeps turning and turning, and sometimes his water is subducted, and sometimes, well, it rises again. But a much more important and bigger, larger, that's circling Antarctica is the Arctic Circumpolar Current. Oops, there seems to have been a problem. I must have made a sort of slight error in my model, change of sign, because theoretically the water should turn in the other direction. Let's start again. Okay, this looks much better. So, apart from that, well, as I said, we are short on funding, so we didn't have enough money to really ask the actors who will be playing Europe or North America or anything like that. But the very important water mass is the North Atlantic deep water. And the North Atlantic deep water is formed, it is very dense and very heavy, and it's subducted. North Atlantic deep water comes towards Antarctica and basically joins the Arctic circumpolar current. But all of a sudden, the Arctic circumpolar current has become extremely strong. It's really a massive current. And actually, the passage in our model, I think we have to do some fine tuning here because the passage between Antarctica and South America is much smaller. So, yeah, that's more the direct passage. So let's start the model again. Okay, so now it's gotten very, very narrow in between here, and somehow the water doesn't seem to fit. So, okay, so some of the water is flowing north of South America. I want to see this one, sorry. And while it's going north, it's going past the north of Australia, through Indonesia, and coming around Cape Gallis. And, well, let's wait for another round, so there we go. So it's going north of Australia, going via Indonesia into the Indian Ocean basin, and then coming around Cape Gallis. And since the Antarctic circumpolar current is so strong, it's really tight in between, so some circulation seems to be happening here that looks a bit like an eddy. But overall, I'm pretty happy with this model at the moment. So I think what we can do is let's do a bit higher resolution. I seem to have convinced my funders to get a little more money. So could I please ask for maybe 3 or 4 more people out of the audience to act? You get some funding, don't worry. I just need to maybe 3 people. Please? Perfect, great. So you basically just join the currents, and remember your water molecules, so you're attached to each other, but it's all kind of relative. Okay, perfect. There we go. Yeah, that looks much more like a But let's try a little spin up. Okay, there seems to be sort of a runtime error. Well, overall it seems to be working, so thank you very much for the extra people. I think we can now put down to going forward to answering our question. Thank you very much. So I have faith in my model now. It's representing raw motion. So now let's focus on the fact, well, what would happen if this passage was closed? And it's not like it's as likely as you think it would be, because they're crazy people in Dubai, and they take lots of sand, and they built a palm, and they're living on a palm now, and they also built like the world. The world is not enough. They want a wall, a beach between South America and Antarctica, so they can go and visit the penguins more often. So the question is really, what would happen if we had such a wall in between? So let's just see what would happen to my model. Okay, this is a little bit chaotic here at the moment. It doesn't seem to really work. So let's do it all one by one and slowly. I think I have to change a couple parameters. So we're still, since this is just a little beach between the 2 continents, and it's very cute. I can actually lie here and relax a bit. But irrespective of that, it didn't change a lot with the topography, so we still have westerlies very strong blowing over here. And then we have a couple of rather weak easterlies. You're going here, and it's turning Rothschild. But there's a lot of water here in the Arctic Superproblem current at the moment. Since this passage is close, it's kind of accumulating. It has to go somewhere. So, in fact, actually, some of it goes and joins the Rothschild. So the Rothschild becomes a little bigger than it was before. Yes, that looks lovely. So, where can the rest of the water still go? There's a big wall in between here. The only other way it can go is really across South America to the north and follow its original path. Great. But since the Arctic circumpolar current, as we knew it, kind of no longer exists, there's no circumpolar component anymore, so it's like an Arctic current. Well, it all comes sort of less circumpolar and less isolated, and it's sort of a bit weaker somehow. And there's all of a sudden also lots more space between the passage between Africa and Antarctica, and the water can pass through because there's no North Atlantic deep water formation anymore. And somehow the Gulf Stream will stop. I wonder what the people in the north feel like. It must be really cold. But I'm used to this. And now that I think of it, it's so warm all of a sudden. It's really like, I'm melting.